Okay. Yeah. Thank you everyone for joining today's event, and we're happy to have Ron to be with us. He'll be talking about deep auto uh, visual and ML. So it's going to be a workshop, and he's going to give us a lecture demonstrating how to use this no-code library. And he's currently a machine learning instructor on Coursera and also a consultant for Google. So let's welcome Ram.
Thank you, Mohammed and Kashan and the CMU Tech and Entrepreneurship Club. I appreciate the opportunity to present this library to you. I hope you're able to hear me.
Yes.
So without further ado, I'll just share my screen, and the host has disabled the screen sharing. If you could just allow me to share the screen. Thank you.
You should be good.
Yeah, I am. So we'll go through the presentation. I have a brief overview of the library. And once we understand the format of the library and how to use it, you'll be able to create what I believe to be very good deep learning models that can help you structure data, classifying images, and NLP. And I'll talk to you about how to do that. So what's the name Deep AutoVIML? It kind of sounds like a little weird, and I understand that. But when I first started in this journey of providing automated ML libraries, I came up with a kind of a differentiated name, and that's called AutoVIML. VIML basically was a brand I grew up with in India, and it's a very famous brand, and it's kind of there's an ad that goes like this: only VIML, and so we all grew up loving VIML. And so when I had the opportunity to name my library, I just decided to give it a cool name, which I thought would be cool. But AutoVIML is a name, and when I found Kai Han-chung having difficulty pronouncing it, that's when I realized it's probably not such a great idea. Deep AutoVIML is just a variation of that. I'll take you to the GitHub and you'll see kind of what kind of features and popularity it's got, and then we'll do a demo and we'll go into why is it needed, right? So Deep AutoVIML is basically the deep learning version of AutoVIML. You can see the other libraries I have given. One is called AutoVIML. The first one I created and released, and the second one was AutoViz. AutoViz luckily has become one of the top 3 EDA libraries for Python for doing data analysis. The first one being pandas profiling that everybody loves. The second one is SweetWiz, which is a very good library. And then the third one, most people think it's AutoViz. So that's a pretty, great opportunity for us to make an impact and contribution. And I decided that kind of spurred me on to do more. So Auto Time Series or AutoTS was my third library, and it helps to automate time series models. And it's got quite a following as well. And then last was the reason I put out a thing called FeatureWiz is because a lot of automated machine learning models require feature selection, and FeatureWiz does that for you. All right, let's quickly get into the topic, how Deep AutoVIML works. It's very simple. The pipeline inside, which you don't get to see, is because you are using a single line of code. The number one kind of way in which I feel people have adopted this library and my other libraries is the single line of code is kind of my signature. So if you see the word single line of code used very often, I apologize, but it's something that I feel very passionately about. I feel that libraries that are easy to use are more likely to be used, but there are other libraries that you might feel have more options. I try to choose the best options for you, so you get a single line of code that does the job for you. If you want to tweak it, then you have several options beyond it. And Next is, so when you provide your files to build a data pipeline for AutoVML, all you have to do is to give a name of the file or a set of files or even a zip file. Because when you look at TensorFlow, it was not created to just read a single file. It can read a star.csv, which basically means any number of CSV files in a particular folder. It can read images, and it can also process NLP text.txt file. When I say images, it can also read .jpg or .jpeg files, .png files, and so on. So all of these files can be read. Only you have to give the folder name, and it'll build a data pipeline. I don't know how many of you know, but Pandas has a limitation of reading very large files, sometimes in the terabytes, sometimes even in the megabytes. It depends on how big your computer memory is or your machine's memory is, because it's trying to load the entire file. When you give a name of a file, Pandas loads the entire file into memory. Whereas TensorFlow basically builds what's known as a pipeline, and it does that by pointing to the file and only asking maybe the first 32 rows to be read. So there's only a pointer to the file. The entire file is never, ever loaded into memory in TensorFlow. The TensorFlow pipeline goes to the file, and you can do caching, you can do prefetching, you can do all those things automatically in AutoVML, and that would enable it to just read just the right amount to create a batch. The batch size can be 32, meaning 32 rows, can be 64 rows, and so on. So you can see here that the data pipeline is a very powerful part of Deep AutoVML, and one of the reasons that it's popular. Second is pre-processing features. When you look at other deep learning libraries that use TensorFlow, they all use numeric features because it's much easier to process them. They'll never show you a text plus numeric or multiple categorical variables with numeric in their demos. The reason is many of them will break because they have to write a lot of TensorFlow code to pre-process them. And especially if you're not using pandas, it's extremely difficult to remember all the TensorFlow commands to make even very simple transformations. It's not as easy as pandas is. So what you'll see in Kaggle and other competitions mostly is people work with CSV files. They do import them into pandas, convert them into numpy arrays, and then they build a sequential model. It works in Kaggle, but it does not work in the real world. Most of the real world data that I deal with are in the gigabytes, terabytes, petabyte range, and none of them will work using pandas. So in this pre-processing, what we do is we do the transformations for each feature, and then we find the best model architecture using a hyperparameter tuner called Storm, which is a new tuner that's come out recently. There's also an existing tuner called OpTuner. You can choose your tuner. I give you the option. Finally, it trains the model on your data, and it gives you the final model to be saved, and you can host your model anywhere. Basically, you can host it on Google Cloud, you can host it on AWS, you can host it on Azure, you can host it on a private, a different provider. So anywhere on your local machine, anywhere you can host your model. So why do we, find this to be attractive? We find that in a traditional machine learning workflow, when we go through all of these steps from data acquisition to predictions, we have to do a number of steps. And AutoVML combines all of these intermediate steps into one single path in the middle, and then you just have to know how to acquire data and how to send it to AutoVML, meaning and give it the name of the folder, and it'll predict. How Deep AutoVML can help you is you can experiment with multiple deep learning architectures with just one option. I'll show you what that option is. You just need to keep giving multiple values to it, and you can try multiple architectures with one line of code. And the same way, the same line of code can be used to do read structured data. The same line of code, the same syntax can be used to learn read images, and the same syntax will work on NLP. You just have to give it the name of the folder. It automatically will deal with this. And that's, I feel very passionately about making things very simple. So that's the reason why it's like that. And finally, it can handle very large data sets, and it'll take very little time. Let me show you how fast it is on a data set. So this is kind of, an internal behind the scenes look at Deep AutoVIML. Many of you might have worked with TensorFlow 1.x until 2.4 came out. This was the standard way to build models. You took your input layers, you took your feature columns, which are basically transformations to the input features, and then you built your Keras sequential model. Here with 2.4, and currently we are in 2.6, TensorFlow basically lets you define the same input layers as before, but TensorFlow has now combined the feature column, got rid of feature columns. Now you've got something known as pre-processing layers that actually sit in the sequential model. What's the benefit of this? The benefit of this is during inferencing, you can take the raw text and feed it, and it will do all the string lookups, the discretization, hashing, the category encoding in the model. So the model can be hosted on AWS, and the data can be somewhere else, raw data. All you have to do is to feed the raw data right to GCP or AWS, because the model does all the transformations. You don't have to write a single line of code or attach these feature columns to the input layer to make the transformations. And then you have to feed only the numeric data to the sequential model, because the model that is stored previously used to only be the model layer, not the preprocessing. Right, so how simple is it? You basically do the pip install of Deep AutoVIML, and you call Deep AutoVIML, import Deep AutoVIML, and give it a name. And you basically can do a fit, and you can do a predict. So Deep Auto will basically be a short form, a shortcut to the whole library, and it's got a fit and predict. The fit basically requires only two things: train and target. The predict only requires the model, the project name, and the test data. But if you want to, like I said, try different architectures, you can try the Keras model type and give it the name. There is an option called auto, which will automatically choose a model for you. And if you want to try fast, it'll take in an input called fast as a Keras model type, and so on. Now, what is this use of a project name? We use that to store the model. So if you give it a project name, very distinctive, saying this is Mohammed's third model, or this is Matthew's fifth model, you can give it that as a project name, and it'll store a folder with that name that you give it. And in that, you'll find your model. And that is only if you set the same model flag to be true. Now, you all know that in Keras, there's multiple options, and it's impossible to compress all of them into these options. So I've decided to turn it into a dictionary. So you can take Keras options equals dictionary, and you can put in any of the Keras options that you're familiar with. In TensorFlow, especially Keras, there's activation, there's all different kinds of things you can play with. And if you feel like the model is not doing a great job, you can give your own activation and so on. And model options are a few things that you need to go to the GitHub to look up. And finally, use my model. You can bring your own model that you have model architecture, and you can train it on this data set. Let's say you created a sequential model with 10 layers, but my model only gives you 3 layers or 4 layers or 5 layers. You're not happy with it. You can use your 10-layered model and use my model and give it the object, the 10-layered model, and it'll use that to train on this data set, right? And predict is all about giving the same model. It could be stored anywhere. You can give it the name of the folder, and then the project name, meaning where is this model stored, and in which project folder, and then the test data set. All right, so what are the different options for your models? For tabular data, the first thing I would use is fast for the Keras model type. I mentioned earlier that there is something known as Keras model type, and that controls almost all of the architectural decisions I make. So if you use tabular data in your data set here, that looks like this, basically structured data, you can say fast to build a fast model. Then you can say fast 1 for a deep and wide model. I showed a camera there, because sometimes you can take a picture that's deep, zoom in, or you can have wide, which means you zoom out, or you have a wide range picture. Same way, you can use fast 1 to build a deep and wide model. This is a model, I would say, that Google came out with a few years ago, and it's become very popular since then. I have found this model consistently beats a lot of other model architectures, but it does not mean that it's the only best model option. But if you're trying fast and it doesn't give you a good accuracy, try fast one, and then the deep and cross, which is a different version of the same thing, is fast two. You'll probably get a very good model. If all of these three fail, try auto for automatic parameter tuning, and that should give you the best model. Auto takes the longest time. Fast takes the least amount of time. So try fast, then fast one, fast two, and then you go auto to build your very complex hypertune model. Same thing on NLP. You can start with NLP by using the word NLP for a text data. You say NLP for the simple model. If you use the word next layer, the next step is use text to get a more advanced model. And if you use the word BERT option, you're going to get a BERT model that takes a long time to train. It takes a long time to load, it's a long time to train. So just be aware. And then if you're using image to train an image classifier, just the word image is enough. Not sure if I have more complex things coming, but I'm always on the lookout for good models. So if I find a good model, I'll make it an option so you can try it yourself. All right, so I've already covered.
I'm sorry for interruption. I think there is, there is a problem with the mic. I think it keeps going with the sound at different levels. So is there anything we can do? I'm not sure if it's my speakers, actually, it could be my speakers. I wanted to ask if someone else is having the same experience.
No, I think somebody's not on mute, that's why.
Okay.
All right, that's good. That's it. Okay. Let me try select a speaker is the same microphone. Okay, let me try this. Can you hear me better now?
That's much better. Thank you.
Yeah, it's model optimized now.
Okay, good. It's great. Sincere apologies. I was using the microphone array from my laptop. Okay, good call. So we are back. This is your typical, I would say, code snippet you're likely to see in Kaggle and in your own sometimes co-workers or hackathons. You basically see them importing TensorFlow, importing Keras, and then basically you take any data set like MNIST, load your data into xtrain, ytrain, xtest, ytest, create your simple sequential model, and they compile it, and they fit on xtrain, ytrain, and they evaluate on xtest, ytest. This does not work in the real world at all, right? Number one, your data set is, terabytes, and if you try to fit it into numpy arrays or pandas, it blows up. Second, this model architecture with 3 layers, starting with 128 down to 10, is probably not the best model architecture for all models. That's right. You have to find out whether 128 is the right number of neurons for the first layer. Is it the right same number, the right one for the second layer? Is activation ReLU really the best one for this particular model? Or is it LU? Or is it CELU? Or is it, TANH? Is it sigmoid? None of us know. And if you are going to try all the options in this can take you days. So this pipeline building, which basically takes MNIST, which is a toy data set, it's got all numeric values. So you don't see any pre-processing layer at all in this. How do you build a pre-processing layer if you've got text columns, you've got categorical columns, and you've got numeric columns, right? You simply can't. So that's why you need this, right? You need Deep AutoVIML. I'm just giving you a flavor for why so many people do this in competitions, and it seems so easy. Why do we need a library to do what you could do in 5 lines of code or 8 lines of code? Yes, you don't need it for this kind of a data set. That is for sure. Right? So if you're looking for something deeper that works on your real world or your enterprise data set, then you need something like Deep AutoVIML. So here's a pipeline for one of the data sets. And for you to build this on your own, I don't know, I'll give you 5 minutes. Oh, okay, maybe I'll give you 10 minutes when I give you my data set. If you can duplicate this, maybe I'll give you a couple of hours, right? You just can't, right? And this is what it builds in like under 5 seconds, 10 seconds. So, you know, so you can't compete with this very easily on just one data set. And if I were to throw real world data sets, you're going to be lost. What is it doing under the hood, right? This is the deep and wide model architecture. So this is the wide part of the model, and this is the deep part of the model. I'll tell you why it's wide and why it's deep. It takes all these features, it does the transformations, it then concatenates them, and then it sends it through just one batch normalization and goes straight to the output layer. Here's the same features, the same, every one of them. You do the transformations of those features, and then you concatenate them. You do the batch normalization, and then you got how many deep layers? 1, 2, maybe 3. So, and you have to do batch normalization after every dense layer, and you got activation layer and so on, right? For you to write this kind of code will take you a long time for just one data set, because for you to figure out the syntax to transform each column here and troubleshoot that will take you a very long time. I tell you, it took me a very long time to master this, just to be able to write it on my own. And then to turn that into automatic code took me a hell of a long time, all right? So the best thing you can do is to basically fork this code and just take it and modify it and look like a genius, because it'll automatically build it for you, and you can basically take that code and modify it. But I'll tell you what it does behind the scenes. It does automatic feature transformation. Second, it does automatic missing value filling. Now, missing value you would think that, hey, it's no big deal, but try doing missing values with TensorFlow, because in pandas it's so simple. Fill an A, all right? Try doing that in TensorFlow, right? And there's 100 different ways to do it. It's so hard. And so somebody gave me a data set and it had no missing values. So I broke my head trying to figure out how could it just my model break, right? And then I found out it had infinite values. So when an infinite value goes through a neural network, basically the multiplications, which are matrix multiplications, basically were failing. And it did not show up in the output because the output was all zeros or all ones. And it had no missing values. And I went back to the person who gave me the data set, and he said, well, I told you AutoML never works. And I said, wow, this is bad. So I went back and started testing all of the data, what was in the data, and I found that it had, like 60% of his data was missing value, was infinites, negative infinity and positive infinity, because he was doing division of one feature by another feature. And when you divide by 0, you were getting positive infinity. When you divided by a negative number by 0, you were getting negative infinity. And I didn't check that, because I typically get data sets from different people and they tell me, Ram, I wanted you to help me with this, and I help them. And after I went back, I fixed the code with including infinite values and went back and did. The model did not actually do that well. Actually, XGBoost beat that, and I'll probably explain later if you're interested why that is. But this is a problem. Next, feature crosses. If you're trying to do feature crosses, here, the deep and wide model, there's some feature crosses being done here, and it'll be even more complex. There's no feature cross here, actually, but if you did that, it would be more, basically, feature crossing means you take feature A multiplied by feature B, and then feature B with feature C, and so on. It does automatic feature renaming. One thing you will find if you use TensorFlow is you will get an error in your data set and you wouldn't know why. And then you go and check Stack Overflow, and then there's 10 different reasons why. Then you come back and you find that that's not applicable, and then you spend a lot of time. What I found was that if your variable had an empty, had a space between the names, TensorFlow actually broke down. So I did not know that. So I had to now concatenate the name of the variable so that there was no space between the name in the name. So those are simple things, but when you're writing a AutoML model, people don't have a lot of patience for you if you make make it very difficult, or if it breaks down on every data set. They think you've built a very stupid model or a stupid library, and you've just thrown it out there. So I always find out what can go wrong and try to fix all of them or most of them before I put it out. Now, some people will show you an MNIST data set. Everything looks good because all the features are numeric, but the target label like Titanic will have survived, yes or no, or survived and did not survive, malignant and so on. That's a label, that's a target label. And if you give it multiple categorical values, then you have to do the label encoding. I do that automatically. And then automatic multi-label, multi-class. Some people will have an AutoML library, but it'll only work if the target is one target column. If it had 5 targets, basically it won't work. Mine works out of the box. It detects if you give it five different targets, it'll predict all 5 at the same time. And it'll do multi-class, multi-label. So there's so much more. I can go on. And basically, you can create, once you train the model can be put out in Cloud AI Platform, which is the platform I'm familiar with. Basically, you can create a model object in Cloud AI Platform using this command. And then your model will already be saved in that folder I told you. And you can take that and you can give it give the model a version name, which is the name here that you'll give your model. And then the origin is where you find the location of the saved model and you give it. And then you make predictions by inputting, let's say, square footage and type are the 2 variables in your model. You can basically say square footage is 3140 and type is the house. You notice that you can send raw text as house in Deep AutoVIML, which you may not be able to do in other libraries. So with that, I think we'll jump into, this is all the things I mentioned earlier, feature engineering. I mean, I told you now, there's just so many features in this. I don't have time to walk you through all of them, and I'm working on other features like this. All right, so we'll take the first example here, which is the Titanic data set. We will do 2 things with it. We will call the auto model feature, which is the auto model option. There's no NLP done on the name. See, in Titanic, if you remember, the name of the passenger is given. Sometimes the names of the passengers are all Smith, and you can find that if one Smith survived, maybe other Smiths survived too. I don't know. But one of the reasons we take NLP and add it to structured data is it provides more information, more signal. And so in this particular case, I tried the auto with NLP character limit set to 10, which means anything over 10 is an NLP variable, anything over 10 characters. So the name feature was input. It did not help the model that much. I got the F1 score 79, whereas I got an F1 score of 82. So that's all good. I mean, in some cases it doesn't help, but in some cases it helps. So what we're going to do is we're going to click this column or click this link, and I'm going to paste this for you so you can actually go there. All right. Okay. So here we are. I'm just trying to see. Are you able to see the screen with the Titanic, or you're not? should I share the screen?
Yes, no, we were able to see the screen, but we didn't get the URL if you aim to.
Yeah.
paste it in the
Okay,
Zoom.
let me give you the URL now.
Thank
All right, so here's the URL, which I'm going to post in the chat box. All right, for everyone. All right. Okay.
Awesome, thank you.
Okay, so there's a few questions. I'm going to quickly go through them because it will help. I'm hearing some references to TensorFlow. It's built on top of TensorFlow. If so, why TensorFlow? Why not PyTorch? TensorFlow is something that I'm comfortable with in Google. I'm not very familiar with PyTorch. Neither I was an expert in SparkML. So that's the only reason, is because I was familiar. If somebody wants to take, all of this and just change it to reference it to PyTorch, it should be good. And second, does AutoVIML handle duplicate column name scenarios? I think it does. Duplicate columns, it does drop some of them, or drops all of them except one. So take a look at that and try it. What kind of imputation will happen on data set? We don't do an imputation. I particularly like to stay away from imputation. I put in the number like -99 or -1, as the case may be for numeric, and for categorical I put in the missing value as missing, and that's it. That's all we do. We don't actually handle any this thing. Outlier and skewness. It's a good question. Don't handle outlier or skewness. It does not seem to affect TensorFlow deep learning models as much, like I said, except for the infinity, which I have taken care of. So the way I handle infinity is I take the next best value other than infinity. So if you had a range of values going up to like infinity, but the next value after infinity was -9999 or 9999, I take that as a value, and I fix the infinite value to that next best value. It's very painful. It took a lot of painful coding to do that, but I felt like I had to do it. All right. Yeah. So Chandler, thank you. Talk to him. Really appreciate this attendance, and I hope this benefits everyone, and you can pass the message along that this is available for your enterprise teams. All right. So let's go to that Kaggle notebook. I'm going to, let me just stop share. I'm going to try the share screen, which is Deep AutoVIML. Right, I've already got it running. So we are going to just run this. All right. So we'll basically say run start session. So it's the session starting, and then we can basically say clear. Takes a little bit of time in Kaggle. I restart and clear cell outputs. You can see that this notebook is very clean. I've written a small utility in Kaggle called load Kaggle, because I find it very painful to read the Kaggle files every time. So I just wrote myself a simple utility. If you go to Kaggle, you can find it by searching for load Kaggle. So my load Kaggle automatically looks for keywords like train, test, or submission in the file name, and it automatically puts them into train, test, and submission. So you can kind of see that I'm constantly writing utilities to make my life easier. And when I find it useful enough, I throw it out there and let other people use it. So that's one reason why this notebook looks very clean. Basically, the Titanic data set is a very difficult data set for most machine learning, deep learning practitioners that use TensorFlow or PyTorch. Their first instinct is to convert this immediately into pandas, make all the changes, write hundreds of lines of transformation code. and then feed it to a sequential model, like I said, and then that's the level of deep learning that most people are familiar with. And there's nothing wrong with that. I think it's perfectly fine. But when your data set is petabytes or terabytes long with even 13 columns, you basically, it doesn't work because you just cannot load that data set into pandas, right? And when you cannot load a data set to pandas, you're stuck, right? How do you transform it? And if you want to learn TensorFlow to be able to transform each one of these features, it'll take you a very long time. And you have to go to Deep AutoVIML because it gives you that model in a box in a very simple way that has the pre-processing layers built in. So what we are going to do is we are going to pip install Deep AutoVIML. And while I do that, I'll just point out a few interesting things about this. The name field, like I said, is about 50 characters long. And if you take my default is 50 characters or something. It's below 50, so it will not show up as an NLP. I try to detect which variables are which. So it automatically will detect the sex variable as a categorical variable. It will automatically detect age as a float variable. It will automatically detect the sibling spouse relationship as an integer variable. It will automatically detect the embarked as a categorical, and the survived, if you give it the target, as an integer or basically numeric variable. So those are very important steps that TensorFlow needs to do. And you can see here that I installed a bunch of stuff like TensorFlow text, the Storm Tuner, Jupyter, and then I also installed something that you like very much, which is TensorBoard. TensorBoard helps you monitor, and I automatically log all of the charts in TensorBoard so you can see it. Right, so here we are. You've got version 67. Just make sure that you've got this version and above. It's been extensively modified. And we are going to choose the fast one. The fast is the fastest way to build a model. So the Keras model type, we're going to choose fast. And I said earlier that the NLP characters should be 50. So if you use 50, you will not find any NLP variables. And I said earlier that Keras options is like a way to modify all of the early stopping, class weights, learning rate scheduler and stuff. These come from Keras. If you know Keras well, then you can easily change it. Just make sure your project name is always different every time. So you get multiple folders, multiple models. You don't overwrite any model. But if you just keep the project name the same, it'll keep overwriting that folder with this newer and newer models. So just remember, I never save model while in Kaggle because I don't really expect to export it anywhere. It runs faster because you don't have to save the model. You can also run accelerated GPU. It runs faster with GPU. So also remember to set GPU. All of these things, small things, but will help you greatly. I'm just going to run this, and it begins to run, right? Now you can see here, there's a lot of classification, meaning what kind of variables. It finds that alert, the cabin has mixed data types. One is float and the string. Embark has mixed data types. So these are things that many model AutoML algorithm will blow up on. I had to go through and find out, how to handle each one of these things, right? And that takes a long time. And you can see the distribution of variables. It does some transformation advisory. It tells you that performing feature crosses will actually be good in this particular case. If you really see this, you will see this as like a data scientist's best friend. It tells you all the things you can do either in deep learning or in pandas. It tells you that the class weights are automatically calculated. So if you are having an imbalanced class, it automatically assigns weights to the rare class so that you get a better model. All of these are done for you, right? Little things help. Keras feature pre-processing. There's no NLP variable, creating the Keras model. Now you can see that it's already run. It's got like a balanced categorical accuracy or balanced sparse categorical accuracy. Now, you would have seen that multiple AutoML models, they build a model and then they use accuracy. And if you had an imbalanced data set, they'll immediately show you they've done 99% accuracy, and there you go home, right? You're so good, but you know that it's predicting all zeros or all ones. So even at the outset, such AutoML models don't take the harder task of doing balanced accuracy as the default. Because if you do balanced accuracy, many of those AutoML tools will show 50% as balanced accuracy, and you will immediately know the AutoML tool is not very good. I'm basically exposing myself, saying that, oh, it's probably not going to be great, but I'm willing to take the hard steps to make sure that we're not giving you a library that's worthless, or it works well on toy data sets, but does not work on any real data sets, right? So these are some of the things you can get to see how the model trains, and how it looks in this screen really tells me how good the model is. It tells me here that the validation has kind of flattened out at 80%, but overfitting, the model's overfitting as the epochs keep growing. And that tells me that that's, pretty good. 20, 15 epochs are probably the best. Here, when I look at the same thing here, I can see that the validation's flattened out on loss. So you can see here the ROC AUC is 80%. 80% for Titanic is a pretty good number for any model. And you can see that it's a very simple model. Straight, all the variables are transformed, straight, dense layer, pipeline. You can see that I've given you F1 score, precision, recall, all of that, right? Every little aspect is thought through for a data scientist. Right? You don't have to spend time, but you really have to have worked to appreciate how it works. Otherwise, a lot of people just skim through and say, well, how is it any better than Keras, AutoKeras, or I can write better code than this? Yes, but it depends on your data set, right? So that's where it is. You can see here your predictions, which is the output. Basically, all I did was to give it the name of the project, the model, and you can see here I give you both the predicted probabilities as well as the actual conversion to ones and zeros, and you can just submit them to. You can submit them and save them, and you're done. Your Kaggle competition in less than a minute. So I hope that was interesting. All right, so let's go to the next one, which is the COVID-19 image classification competition. This is the COVID-19 image data set. I'm not going to run it because it takes a little longer, but it's a very similar, so I'll just show you the same import, the same fit. The target variable is actually a variable called COVID-19. You don't get to see the data because the data is actually in a folder called image dataset folder. And if you look at the images, I will show you the images in a second. They're not a CSV file. They're a bunch of image files. So you need to give it the name of the image directory. You need to give it the height of the image, the width of the image in channels. And typically, if you take these defaults 224, you should be good. But sometimes they do tell you what the image height and width is in the competition itself, and you can easily apply that. And here, you haven't changed much. As you can tell here, only this was changed. And you can see that there's not much else here. And then it runs with, I don't know what option I chose. I chose, what is a Keras model type? I chose image. I said earlier that image is just one of those things where I haven't found too many interesting models. So I've just chosen a basic model for you for image classification. And you can, it's called MobileNet, and it actually does about 89% accuracy. And so it shows you examples in the validation data set. So something that's a normal X-ray, it predicted as normal. Something that was viral pneumonia, well, this is just a sample. There's no predictions here. I'll show you the predictions in a second. So basically, it takes a set of X-rays and shows the predictions on those that it made. So on a COVID actual label, it predicted it was COVID. On a normal, it predicted normal. On a COVID, it predicted. So it seems to have gotten about 100% of these correctly. On a validation, it's up to you to run it on the test data set. I've run it, and basically it did pretty well. And the fun part about Kaggle is AutoVIML is never going to get you a very high rank. The feature engineering and all of that is what is going to get you the higher ranks, mostly, right? And then we'll go with NLP. I've chosen the disaster NLP, disaster tweets. This is kind of one of the most interesting data sets in Kaggle for social media tweets. Basically, somebody tweets and it's about a disaster, so it's relevant, or it's not a disaster. So we choose the target as choose one, which is the name of the target. We didn't have to do much. We can only see what the target value counts are, relevant, not relevant. We will drop the 16 rows. The reason we drop the 16 rows is that they themselves feel in Kaggle competition, those 16 rows are kind of an anomaly. So out of the 4,000 or 10,000, we're going to drop 16. So there's about 10,000 rows. We don't do much here, except we choose I think we choose the model type. So the model type here that I'm choosing is NLP. I mentioned earlier that NLP does a slightly better or complicated model. Let's see how well it does. So it takes the data set, builds a very simple model. It's got about 70, I think, percent. So it's got like 70% balanced accuracy, which means RSC AEC is in the 83% range, 78% on the validation data set, F1 score about 78, and then make the prediction. And you can see that I had chosen a test data set just to show, and the test data set, it does about the same 78%. So it means that the model trained well, that what you're getting in validation, you're getting in test. So with that, we come to the end of the presentation and the demo, and we'll take questions. Okay, so how many data sets have you validated this library against? Well, I'm constantly playing with Kaggle data sets. I participate in hackathons just to test this AutoVIML. I don't have a number, but it's quite a lot. And you can see, every week I put out something on my LinkedIn profile of someone who has either used this or I've used one of my libraries. And if you go to, Kaggle home, I'm not sure, are you able to see my screen with the Kaggle home? With
Yes.
Okay,
Yeah.
good, with my photo. If you go to Kaggle home and basically look at my profile, you should be able to look for code. And in the code, if you look at my work, basically you can see all the different data sets that I've applied this on. Now, this is right, just one small portion, because like I said, I participate in hackathons, which are not here in those other things. So, right. In terms of image processing, the rescaling, it doesn't rescale. It just takes as is. So you got to give the size of the image. So you have the image parameter, size parameter, just give it. How optimal hyperparameter. So optimal hyperparameters are tuned using something called Storm, which is a new tuner that has come out. And if you take the Storm tuner, this is one of the fantastic tuners in the market. And basically that tuner helps you behind the scenes to build a model. So it takes a sequential model. It tries different batch sizes. It tries different model dense kernel sizes. It also tries different layers. It tries the activations. It tries out dropout values and so on. That's what I'm using underneath. All right. More interested in pre-processing, how the categorical values are converted to numerical. This is really a good question. Categorical encoding. So if you type in category, right, encoding, and we'll put in keras, right? So I use the category encoding layer of the TensorFlow 2.6, and you basically can read about this, and you've got multiple examples here. I don't use one hot. I use something that's either count. I think output mode is either count. Yes, I think it's either one hot or count. It depends on the data set. If you have a data set that might result in thousands of variables being created, I automatically turn that into count or multi-hot. But if it's only got like 5 different levels like this, and it turns into 5 variables, I make that into one hot. Right? Anything else? All right, 2 minutes to spare. So this, it's basically licensed as a Apache 2 license, and I think you should feel free to use it in your class, in your enterprise, in any setting, as long as you use it under the terms of use of Apache 2, whatever that is, you should be good.
Awesome, thank you.
Yeah, you're welcome.
Awesome. So thank you all for joining for today's activity. Let's give a big round of applause to Ram for doing a successful job. And we'll see.
It was a great talk. Thank you, Ram.
Thank you so much. We will be posting this event online to our YouTube channel within the next few days. Be on the lookout. And then we'll see you at our next community event for TNE CMU.
Yeah, and I'll send the PPT that I used as a PDF, and you should be all able to take that and review it at your leisure. Thanks a lot for everyone for attending and giving me a chance to speak to you.
Thank you.
Thank you so much.
Bye. Thank you all.
Bye.